Okay, so for question 6, I want to prove that the included angles are the same. So these are the angles that I want BCE and ACD. Okay, so this angle is found over here, ACD. Let us break down this red angle into two parts. Obviously it is over here 60, right? Plus a certain angle, which is, let's call it X over here. It's fine if you don't want to let it be X, can just call it ACE. So let angle ACE be equals to X. Yeah, it is equilateral, but you see, I want to prove that this included angle is the same as this angle. At this point in time, I cannot show that they are the same. But what I can show is that this angle is actually broken up into ABC plus ACE. Okay? Which means it is 60 degrees over here plus ACE, right? One angle split into two parts. Okay, Sophia? Okay. First, do you agree that we need to prove that this angle and this angle are the same? The two red angles, we need to prove that they are the same.
Why cannot just use ECE and
ECB, ECD, ECD, and what? ABC, but ABC, this angle, but they are not parts of the angle that of the triangles that they want, BCE and ACD. So I have no choice but to compare these two angles in red. They are the included angles. Yes, they are our included angles. This angle is broken up into 60 degrees plus a certain angle, let us call it X, or we can simply let it be ACE as well. Okay, so here we have 60 plus X. What about the other angle, ACD? On the other side, it is also 60 plus X. So although I don't know the values of the angles, I do know that they are the same. Get it? Okay, so my final line. Angle for this triangle on the left, BCE, is equals to 60 plus angle ACE. And on the other side, the other triangle, angle ACD is also equals to 60 degrees plus angle ACE. So I conclude that this is equal to angle BCE. So by SAS congruency test, blah blah blah. Get it? So this is one way that we can prove that angles are the same without actually knowing the values. Because the X in the middle, the ACE, is a common angle. Okay, go and watch the video if you still cannot get it. Next, 7. Show that ACD is congruent to ABF. So see, I'm always consistent. I always draw the two triangles, or rather draw one of the triangles so that I can see straight away where are my corresponding sides, where are my corresponding angles, so that I can tell what are the same. So by drawing it this way, I know that AC is equals to AB already. I've got one side that is known. I've got an angle over here that is known. If I have a side and I have an angle, do you want to try using SSS? No, right? Might as well find either another angle or another side already, right? Okay, so comparing these two triangles in yellow, do you want to find another side or another angle? Side angle? Angle. Okay, which angle you want to find out? 180 minus X. Which angle? What's the name of the angle? CDA. CDA. Okay, so Junior wants to find this angle. This is 180 minus X. So, what happens next? Okay, so let me just write it down first. ADC, this is 180 degrees minus x. And what is the other angle? BFA. What is this angle now?
180 minus. Then do 360 minus.
Still need another angle, man.
Why don't you?
What do we have now? Now I have two angles with two triangles, and I have one common side, right? Which test do you think I want to use?
SAS.
Huh? I've got two angles.
Oh, RHS. RH. Yeah, right.
I've got two angles. I've got one side. ASA with two angles and one side, right? Then I want the side to be in the middle. Right now I have angle, side. I want angle, side, angle. So how?
Might as well do SAS.
SAS, do you have another side? Where do we have the same side again? I only have the red color lines being the same. Can you prove that FA equals to DA? If you cannot,
So is it 180 minus 90 minus?
yes, you're right, to find the last angle.
Yeah.
If you cannot find that FA equals to DA, you cannot prove that FB equals to DC, then you cannot use SAS. You cannot use SSS. You must use ASA. And finally, since I've got two angles being the same already, then all that's left is to find this angle and prove that it is equal to this angle by using angle sum of triangle. So angle ABF equals to 180 minus minus 90, then minus away that 180 minus x. And then we'll see that this other angle ACD also equals to 180 minus 90 minus 180 minus x. And we say that this is equal to angle ABF. So using the ASA congruency test, these two triangles are congruent. Can?
So you leave it.
Yes? Hey, never mind. Okay, name another pair of triangles. They didn't ask you to prove, so you can just name it. What is another pair? What is another pair of congruent triangles? CAB. CAB. CAB is this big triangle.
Yeah.
It congruent to what? Cannot. Okay, yes, Harif. CFB and naming is very important. CFB and
Oh, CFE and BD.
so CFE and BDE. Yes, these two congruent. Need to prove? No need. They ask you name only. You managed to prove, okay, if you want me to check, you can show it to me, lah. Okay, 5 more minutes. Let's go on to question 8. So prove that triangle this is similar to another triangle. Draw the smaller triangle out, put in all the information. Okay, what is the method, the test to prove that these two triangles are similar?
Two sides and one common.
Okay, two sides. The ratio of the two sides are the same, right? So which side over which side?
BA over CA.
BA over CA equals to 6 over 8, which is 3.
6 over 15.
Huh?
6 over 15.
BA over CA.
DA.
Wait. Now to prove that ACB, the small triangle, is similar to AED. So big triangle and small triangle. Okay. So what is the ratio of the sides that we want to compare for the big triangle and the small triangle? What? BA. BA equals to DA? Why? Why is BA equals to DA? No. To prove that these two triangles are similar, we want to find either ratio of sides or angles that are the same, right? Which one is easy? You're comparing angle or sides?
Side.
Sides. Okay, which two sides you want to compare? A C over AE. Okay, why AC over AE? Because this side is corresponding to this side, right? Okay, how much is that?
8 over 20.
8 over 20, okay, which is divided by 4, 2 over 5.
Then correct lah, AB over AC.
Next one.
AB over AC.
Why AB over AC?
AB over AD. Sorry.
AB over AD. Okay, what is that now? 6 over
15.
15, which is 2 over 3 again. Now I have two sides, ratio is the same. Sorry, 2 over 5. Yeah. Okay, so what else is missing?
The one common angle.
One common angle or the ratio of the other side, right? I cannot find the ratio of the other side, so you must have a common angle. What's the common angle?
EAD equals to
So EAD equals to
BAC.
angle CAB. So triangle ACB similar
Reasoning. Common angle.
to triangle AED. What is the reason?
Ratio
Of
sides and ratio
and okay, please go and memorize this.
So you don't have to put the reason for the fraction.
Fraction no need. We are just finding the ratio of the sides.
Then the angle.
Angle, okay, this one we need. This one is common angle. Okay? And last one, BC is 9. BC 9. So find DE.
That's the scale factor.
Scale factor, how much is the scale factor? So removing all this, I want to find DE. So I put DE at the top left hand corner. Okay, so DE divided by what? BC equals to? What is the fraction equals to?
AB of AC.
Value, I want value. DE over BC. Small one over the big one. Wait, no. A big one over the small one.
15
Value. 15 over 6, which is
2 over
5 over 2. Correct? Okay, so now it's time to substitute in values for BC. DE over 9 equals to 5 over 2. DE equals to 9 times 5 over 2, which is 45 over 2, 22.5 cm. Okay? Okay, last one. 30 seconds. Need me to show you that they are similar? No, right? This one very easy lah. Common angle over here. We got one common angle, and I've got
Period.
no corresponding angles. Okay, this shape over here, they are corresponding angles.
Then after that, I say of parallel lines. Is it?
Corresponding angles, parallel lines. Okay, so these two triangles are similar. Done. BD is 2 times of DA.
1 over 2.
So over here I've got, take note 2 units. I'm not saying that it is 2 cm, I'm not saying it's 2 kilometers or whatever. Because I don't know what units we are using. We only have the ratio. So find DE over BC.
1 over 2.
DE over BC, okay, this is 1 over 2. Hey, wait, no, it's not 1 over 2. This is a trick question. Yeah, how much is it? No, it is not.
Then
Come on, how much is it?
1 over 2, what, sure?
1 over 3.
Why?
Great, think about it, why is 1 over 3,